Welcome to this predicted paper from On Maths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our On Maths site. On Maths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. So 7 times 10 to the power 4 is going to be 7, and it's going to be 70,000. And 9 times 10 to the power of 7 will be 90 million. And so when you add them together, you get 9007000. Now, if you have access to a calculator, if this is on the calculator paper, then you can just type it into your calculator. Some people think there's a quick way of doing this, like adding the 7 and the 9. There isn't. You've just got to work out what this number is, work out what this number is, and add them together. We know that when you multiply powers with the same base, and here we've got all these as base v, you add the powers. So we're actually looking at what do we add to 11, which is this one here, to get to the 15. 11 plus 4 is 15. So W therefore equals 4. There's an awful lot going on in this question. Whenever there's an awful lot going on, it's always best to draw a diagram. So we're going to start off at Chiltern, which is a C. Then we go to Bolko, that's where we're going. And we go through Devley on the way. So we'll do D there. Distance from Chiltern to Devley is 34 miles. Distance from Devley to Bovlo is 16 miles. So I'm just reading through the question, adding it to my diagram. David leaves Chiltern at 9 o'clock. He drives from Chiltern to Devley an average speed of 68 miles per hour. And what speed does David travel between Devley and Bolko to arrive at 9:45? So the whole duration of this, the whole thing needs to be 45 minutes or 0.75 hours. And the entire distance is 34 plus 16, so that would be 50 miles. Okay, now having a look at this, we need to find out what time David was at Devley. So we're going to use our speed, distance, time triangle. So speed equals distance over time, and we're covering up the time because that's the one we want. So it's going to be time equals distance, which is 34, over speed, which is 68. So we're going to do 34 divided by 68, which is 0.5. So it would be 0.5 hours. So that would be half an hour. So we will be at Devley at 9:30. So that means we've got 15 minutes left. Okay, so we've got 15 minutes to travel the 16 miles. So this time we're looking for the speed. Okay, so it would be speed equals the distance, which is 16 miles, over time, which is 15 minutes, but we need that in hours, so that would be 0.25 hours. And so what we can do here is times top 1 by 4 to get rid of the fraction. So it becomes 64 over 1, or just 64 miles per hour. So our answer is 64 miles per hour. The first thing we need to do is work out the area of the floor. And you'll notice that this is a trapezium. So with a trapezium, the formula is half a plus b times h. And A and B are the parallel sides. So these ones are the parallel sides, and the height is the one connecting the two bases, the two parallel sides. So we're going to start off by writing down the formula. So it'd be half a plus b h. So half times 2.8 plus 1.2 times 11. And when we do that, we get 22. So the area of the floor is 22 meters squared. And it says here that the tiles are sold in packs which cover 3 meters squared. So if each pack covers 3 meters squared, we're going to do 22 divided by 3, which will be 7.33 packs that we need. Now obviously you can't get 0.3 of a pack or 0.33 of a pack, so we're going to have to get 8 packs and just have some left over. So we'll need 8 packs in total. Okay, the next thing we look at is the fact that the Jenny has a 25% discount. So we need to find out what 25% discount would do to the £18.60 for the tiles, or for the pack of tiles. And so what we're going to do is we're going to get the £18.60 and we're going to times it by 0.75. So we're just going to find 3/4 of it because she has a 25% discount, and that would be 1,395. So that's the tiles are going to cost £13.95. Now I've done this in pence and I've kind of muddled it together here, so really let's just go back because I've kind of done this in pence. So that would be 1,860 times 0.75, and so each pack will cost 1,395, and the reason we're doing this in pence is the answer needs to be given in pence, so I might as well just make that conversion now. And so it's going to be 8 lots of the 1,395 pence packs, which will cost in total 11,160 pence, or £111.60. But Jenny has £100 to spend, and we're asked how much extra does she need. So we're going to do the 11,160, take away the 10,000 pence that she has, which will give us 1,160 pence. So she needs to find £11.60 or 1,160 pence from somewhere. So the symbol here basically means and the way I remember it is if you draw that symbol and just put a line through it, you can make the word and. So we're looking at the probability of getting something that is in A and C. So the only ones that are in A and C are this 8 and this 9 here. So we're going to just add the 8 and the 9 together, which give us 17. Now we need to then work out how many numbers there are in total, so that's all of them. So 4 plus 8 plus 9 plus 5 plus 8 plus 3 plus 11 plus 6. So we need the total, which is 54. And then we get the 17, and we put that over the amount in total, so over 54. This question seems a lot harder than it is. What I'm going to do is I'm going to start by rewriting the prime factors, but without the squared. So 2 times 3 times 3 times 5 times 5. I'm going to do the same with the other lists as well. So 2 times 2 times 3 times 11. Now I'm going to put these into a Venn diagram. And so I'm just going to draw out a Venn diagram and get my 2 circles, because we're going to have the 450 and the 132. So 450 is on the left hand side and 132 is on the right hand side. And we're going to start just filling out the Venn diagram. So they both have a 2 in them and they both have a 3, but 450 has a 3, a 5 and a 5. And 132 has that 2 and the 11. Now to find the lowest common multiple, what you do is you just multiply all these numbers together, and that will give you the lowest common multiple. So what we're going to do is we're going to do 3 times 5 times 5, which are the numbers on the left, times 2 times 3, which are the numbers in the middle, times 2 times 11. And when we do that, we get 9,900, and that's it. So our answer is 9,900. So here we're asked to factorise a quadratic, and our answer will be x plus or minus something, x plus or minus something. So it'll be 2 sets of brackets with an x at the start. Okay, so to be able to find out what's in the bracket, we look at the 36 there, and we know that we're going to have to multiply 2 numbers together to make that 36. And we look at the coefficient of the x, that 15, and we know we're going to have to add these numbers together to make that 15. Now, if you just can figure out in your head the answer, that's absolutely fine. If not, you can just quickly write down the factors of 36. Now, because they multiply together to make a positive 36, they'll either both be positive or both be negative, but they add together to make a positive number. So we're just looking at the positive factors. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. And we're looking for which ones of those add together to make 15. And we can see here it's going to be 3 and 12 add together to make 15. So our 2 numbers are going to be plus 3 and plus 12, or the other way around. So we're given 21 to 4 is the ratio. We're just going to have our lines in, because what we need to do is make the left hand side be 1. Okay. And to do that, for 21 I need to divide it by itself, divide it by 21, and we're going to do the same to the right hand side. So 21 divided by 21 is 1, perfect, that's what we wanted. 4 divided by 21 is 0.190 blah blah blah. It says it wants it to 2 decimal places, so it's going to be 1 to 0.19. To find out what the value of x is, we first of all have to find out what the value of y is. And we can notice that we've got 2 sets of parallel lines here, and a line going through them. And we kind of got these f angles, which we have to call corresponding angles. So we know that 2y minus 50 is equal to 78. And we must write down the reason, so corresponding angles. And corresponding angles are equal. Now here we've got an equation and we want to solve it, so we get our lines in. We'll go first of all add 50 to both sides. So we've got 2y equals 78 plus 50, which would be 128. And then we're going to halve both sides, or divide by 2. So we've got 64. So we know that y is 64. And so we look back at the diagram to find out how we'd work out x. Well, what we can do, there's a few different things we can do. We could work out the fact that these two here are vertically opposite. That would be absolutely fine. But actually, if we look at this part here and this part here, these are also 2 parallel lines, and we've got this angle here and this angle are going to be alternate. So I can write that down here. So angle ECB is equal to 78 degrees. So this will be 78 degrees. And the reason for that is alternate angles. And then finally, if we know this is 78 and we know that this is 64, because we know what y is, then we can work out what x is. So x equals 180, angles in a triangle, take away the 78 we know and the 64 we know. And the reason for that is angles in a triangle add up to 180 degrees. And just make sure you write down all the reasons as you go. And when we take away the 78 and the 64 from 180, you get 38. So x is therefore 38 degrees. We know that all linear graphs follow y equals mx plus c, with m being the gradient and c being the y-intercept. So looking at this equation here, we've got c is positive 5. So we know the graph is going to hit the y-axis at 5. So let's plot that. And we know for every 1 it goes to the right, it's going to go up 2 because the gradient is 2. The number before the x is 2. So if we go 1 to the right, it's going to go up 2. So that would be 7. Then another 1 to the right, it's going to go up another 2. So that's going to be 9. So that is going to be 7. And then that's going to go up to 9. So we've got to draw it in, and make sure you do it draw the line for the whole graph, not just the points that we've just plotted in. And it should be something like this. So the first thing to do with these questions is figure out what information we have. So the question says that we are accelerating a toy car at 6 meters per second squared. So the acceleration is going to be 6 meters per second squared. And it says it's going to be for 14 meters. Now, that sounds like a distance, but in the context of these questions, because we're talking in vector terms, it's called displacement, and weirdly we use the letter S to show displacement. So the displacement is going to be 14 meters. Now it looks like we don't have any more, but actually it says from rest. So the initial velocity therefore would be 0, because from rest means it wasn't moving at all at the start. We're looking for the final velocity, so we're looking for v. So let's have a look at which formula we're going to use. So it's not going to be the top one because we're not given time. It's not going to be the second one because we're not given time. So it's going to be that third one. So we've got v squared equals u squared plus 2as. So we're looking for v, so I'm just going to leave that v squared there. U squared, well, that's just going to be 0 squared plus 2 times the a, which is 6, times the s, which is 14. And when you do that, you get 168. And we've got v squared equals. So we need to do a bit of solving here. We need to do the inverse of square, which is square root. So we're just going to square root both sides to get what v equals. So square root of 168 is 12.961, etc. And we're going to round to 2 decimal places, which will be 12.96. So we're given a right angle triangle here, and we're asked to find length AC, which is this length here, and we're given 2 other lengths. So we're going to be using Pythagoras. Pythagoras involves us labelling the sides A, B and C, with C being the one opposite the right angle. And we know Pythagoras is A squared plus B squared equals C squared. Both A and B here are 4.9, so it'd be 4.9 squared plus 4.9 squared equals C squared. So we're going to add the 4.9 squareds together, and that will give us 48.020 blah blah blah. And here we're going to do a bit of solving. So we're going to square root both sides to find out what C is. So square root of 48.020 blah 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 is 6.929 blah blah blah. Rounded to 2 decimal places, this will be 6.93. So with each of these pools, try and imagine it being filled. So pool A, first of all, we've got water coming into it, and it's actually going to go quite quickly initially, and then it will hit a point at the end where actually it will go really quite slowly because it's a wider pool. So we would imagine that the graph for pool A would actually go quite quickly at the start, and then at the end it would go much slower. And that doesn't really describe, the red graph doesn't really describe that at all. So for pool B, we start off actually quite quickly because it's quite thin, and then we have a wider bit here, so it will go slower here, and then we go quickly again. So we need a graph that starts off quite quickly, then goes slowly, and then goes quickly. And the steeper the graph on our depth time graph, the faster it's filling up. And That red line doesn't really describe that either. Pool C, however, we can see it goes slowly at the start, and then because it's thin it will go quicker, so nice quickly, and then it will go slowly again. Well, that is a perfect description of the graph that we're given. So the graph we're given is definitely going to be for pool C. So when we say y is directly proportional to x, what we mean is whenever x doubles, y will double. Whenever x halves, y will halve. Now, we've got this proportionality sign here. And to make that an equals, all we need to do is introduce a k constant to the right-hand side. So it's y equals something times x. Now, to find out what that something is, to find out what that constant is, what we're going to do is feed in the value of y and the value of x that we have. So we're going to feed those in. So y is 55.3 and x is 7. So it would be 7k. And we're just going to put our lines in and solve this. So it's going to be divide by 7 both sides. And 55.3 divided by 7 is 7.9. And that's what k is. So we're going to rewrite this equation here, this formula here, y equals 7.9x. And that is actually our answer. When something gets to the power of 4, you times it by itself 4 times. So we're going to do that to the x cubed here. So we've got x cubed times x cubed times x cubed times x cubed. Now when two powers of the same base are multiplied together, you add the powers together. So here we're going to add the 3, the 3, the 3 and the 3. And that will give us x to the power of 12. Now there is a simple rule here that we can use. Whenever you've got a power on the inside of a bracket and a power on the outside of the bracket, all you need to do is multiply them together. 3 times 4, which is 12. There are two rules for things to be in direct proportion. The first rule is you must have a straight line, which we do on this question. The second rule is it must go through the origin. So we're looking for a line like this or like that, somewhere in that region there. Now, this red line does not go through the origin, so A and B cannot be in direct proportion. Something we know about rectangles is opposite sides are equal, so these two will be equal. And these two will be equal. And you notice now that we've got simultaneous equations. So what I'm going to do is get the coefficient of the y the same. And I'm going to do that by multiplying everything in the second equation by 3. So we get 6x plus 9y equals 123. And I'm just going to write in the first equation underneath, because with simultaneous equations we work downwards. Now looking at the signs, they are the same, and the s in same is the s in subtract. So we're going to subtract going downwards. We're just going to subtract going downwards. So 6x take away 3x is 3x. 9y take away 9y is nothing, which is good. That's what we need. And then 123 take away 93 is 30. We're going to get our solving lines in, and we're just going to divide by 3 both sides. So we've got x equals 10. So we know what x is, but we need to find out what y is. So what I'm going to do is I'm just going to pick one of the equations. I could pick the 2x plus 3y equals 41 and just substitute the value of x in. So 2 times, instead of x, it's times 10 plus 3y equals 41. So it would be 20 plus 3y equals 41. Get my solving lines in. And we're going to take away 20 both sides. So we've got 3y equals 21. And then we're going to divide by 3 both sides if I don't run out of room. So y equals 7. So we've got x equals 10, y equals 7. Now I could check that with the first equation as well. So 3 times 10 is 30, 9 times 7 is 63, 30 plus 63 is 93, so we know we've got it right. When it's said that y is inversely proportional to x, it means that y changes as 1 over x changes. And to write this in an equation, all we do is we just write y equals k over x. Now k is something we need to find. So what we need to do is find out what a value of y and a value of x are somewhere on the graph that would be formed from this, and we've got that in this question. So we know that when y is 7, then x is going to be 7.9. And what I need to do now is just draw my lines down. And what I'm going to do is I'm going to just times both sides by 7.9. And so we have k equals, and it'd be 7 times 7.9, which is 55.3. So we know that k is 55.3. So I'm just going to rewrite this equation here, or this formula here. But instead of k, I know that it's going to be 55.3. So our answer is y equals 55.3 over x. There are a few different ways you could answer this question. I'm going to do it with a tree diagram, but you didn't need to draw a tree diagram to answer this question. So we've got our first tree, which is our first bus. And the choices are male and female. And we've got our second kind of branch, I suppose. And it's still male and female. And this is our second bus. So the property of male on a first bus is 9 over 15. And therefore the property of female is 1 minus 9 over 15, which would be 6 over 15. Male on the second bus is 7 over 15. And so female would be 8 over 15, because they need to add up to 1. And it's independent, so these will be the same. And the question is basically asking what is the probability that both will be female. So to have both female, we need to have gone down this line at the start, and then this line again. Okay, so looking at the fractions along the way, it's 6 over 15 and 8 over 15. The word "and" in probability means times. So whenever you're finding the probability of getting to an outcome, so this outcome would be FF, because they're both female, you are multiplying the fractions that you go across. So it would be 6 over 15 times 8 over 15. So 6 times 8 is 48, and times the bottoms, 15 times 15 is 225. Now you can actually cancel that down. So what you can do is you can divide top and bottom by 4, and that will give you 16. Is it 4? No, you can times top and bottom by 3, and that would be 16 over 75. So either 48 over 225 or 16 over 75. When you have a number next to a letter, it's the same as putting a times there. So we're just going to write this out, but by putting times symbols in. Put the numbers together and the x's together. So here we've got 3 times 7, which is 21, and x to the power of 5 times x to the power of 4. Whenever you multiply bases with powers, you just add the powers as long as the bases are the same. So they're both x to the power of something, so we're just going to add the powers together. 5 plus 4 is 9. We're told here that y is proportional or inversely proportional to x, so we put 1 over x. Because it's inversely, and inversely means it's going to be proportional to 1 over. I'm going to replace that proportionality sign for an equals, and to do that we need to multiply the right hand side by k, so it becomes k over x. And we're told that x is 7.9 when y is 10.27, so we're just going to substitute those both in so that we can find out what k is, what our constant is. I do a bit of simple solving by multiplying both sides by 7.9. When I do that, I get that k is 10.4. Go rewrite our equation we wrote here, but this time with our k value in, which is 10.4. And we're asked to find out what y is when x is 8. So we just do 10.4 divided by 8. And when we do that, we get 1.3. We're going to start by focusing on the a and b, which is 8 and 16. So in the middle is going to be 8 and 16. The next thing we're going to focus on is the fact that a is all the multiples of 4. Now 8 and 16 have both already been taken because they're in the middle. So the remaining multiples of 4 are the 4 there and the 12 there. So the next ones I'm going to focus on is the a or b. So a or b is in a, in b, or in the middle. So if we cross out the ones we've already used, so we've already used the 8 and 16 and the 4 and the 12, that leaves the 1 and the 9. We'll cross that out of our other list. And there's only 2 left in our everything list at the top. We've got the 3 and we've got the 11. So on the outside we have 3 and we have 11. Acceleration is change in velocity over change in time. So change in velocity where it starts at 0 and goes up to 150. So that would be 150. Over the change in times. Well, the time starts at 0 and goes up to 5, so that's 5. And so 150 divided by 5 is 30. The velocity is in meters per second, the time's in seconds, so the units will be meters per second squared. So it's 30 meters per second squared. So what's happened here is that the company's increased the amount of sweets by 15%. So we're just going to focus on that and work out what the multiplier would be first. So they started off with 100%. And they added 15%, and then therefore they ended up with 115%. And to find that as a multiplier, we get the 115 and divide it by 100, and that gives us 1.15. So that is the multiplier they used. Now they used that multiplier on the original amount, and they times it by 1.15, and they got the answer of 69. But if we're working the other way to find out what they times by 1.15, we get that 69 and we divide it by the multiplier. So if we want to work out what the original number was, we divide it by the multiplier, and that gives us 60. So the answer will be 60. First things we notice with the simultaneous equations is that the coefficients of the x and the y are different. And so we're going to just focus on the y's. We've got a 3 and we've got a 5. So we've got to make them the same. So we're going to look for the lowest common multiple. So 3 and 5 is going to be 15. And we could have looked at the x's, but I always look at the y's. So we're going to make the coefficients of the x both 15. So let's write out the first one, get our lines in. And to do that, we're going to times everything by 5. So it's going to be 10x plus 15y, which is good, that's what we wanted. And then 16 times 5, which is 80. Do the same with the next one. So we're just going to copy out the equation, get our lines in, and we're going to times everything by 3 this time to make the y coefficient 15. So we've got 3x times 3, which is 9x, 15y on the next one, and then 25.5 times 3, which is what, 76.5. And we're going to write out the two equations we've just worked out again, but this time next to each other, so we can do our simultaneous equation magic on them. So we're going to do our circles first, and simultaneous equations are all about going downwards. So we're just showing what we're doing. We're going to either add or subtract each of these. Now, to find out whether we're going to add or subtract, we look at the signs of the y's. If they are both the same, we are going to subtract. If they are both different, then we're going to add. So S in same, S in subtract. The D in different is the D in add. Now looking at them both, they are both the same sign. They're both plus. They're both positive. So we're going to subtract. But we're not just going to subtract those. We're going to subtract all three of our circles. So we're going to put our line in here. And we're going to do 10x take away 9x, which is just x. 15y take away 15y, which is nothing, which is good. That's what we want. And then we're going to do 80 take away 76.5, which is 3.5. And here we're left with x equals 3.5, which is brilliant. But that's only half the job, because we've then got to work out what y is. So I'm going to substitute x into this first equation here. So we're going to do 2 times 3.5 plus 3y equals 16. And we're going to get our lines in. And the first thing I'm going to do is 2 times 3.5, which is 7. So we're going to subtract 7 from both sides. And we've got 3y equals 16 take away 7, which is 9. And then we're going to divide by 3 both sides to get what y is. And so 9 divided by 3, which is 3. Now we can check this by substituting that in to our second equation and see whether it equals 25.5, which it does. So we've got Billy and James and Sam. And James collects 20% more sand than Billy. So we've got James and he's plus 20%. And Sam collects 60% more sand than James, 60%. And you'd think you'd just add the two. Obviously, it's not going to be that easy for 3 marks. So the answer is not 80. What we've got to do is find the multipliers for each of these. And so what we're going to do is we're going to start off with 100%, add the 20%, and that would be 120%. Then we're going to get the 120, divide it by 100, and that gives us the multiplier, which would be 1.2. So the multiplier from Billy to James is 1.2. So however much Billy has, if we times it by 1.2, we get James's amount. Do the same for James to Sam. So start off with 100%, add 60, is 160%. Then just make that a decimal, so 160 divided by 100, 1.6. So if we multiply anything by 1.6, it will increase it by 60%. Now it says, by what percentage is the amount of sand collected by Sam greater than the amount Billy? So what we're going to do is we're going to start off with Billy being 100%. Okay. We're going to times it by the 1.2 and then times it by the 1.6 and find out what the final percentage is. So when we do that, we get 192. So we started off with Billy's 100. We just made that up, but it just makes the maths nicer to use. And we ended up with Sam having 192. Well, what is 192 as a percentage increase of 100? Well, the reason we picked 100 is we can clearly see that it's gone up by 92%. So our answer is 92%. This question is the same as questions you get where you've got y equals 8x squared and you've asked to find what y is when x equals 3. The questions are exactly the same, but instead of y we write f of x. And this is saying that the function is 8x squared and we want to feed in the 3 into the function. So it's going to be 8 times 3 squared, and 3 squared is 9 and 8 times 9 is 72. So the answer would be 72. So to draw a box plot we need 5 points. We need the lowest point, lower quartile, median, upper quartile and highest point. Now we already have the lowest and highest points, so we can put those onto our box plot now. So the lowest point is at 0 and the highest point is at 30, as we can see on the cumulative frequency graph. So we need to now find out where the median is. Now the graph goes up to 20, the actual line goes up to 20, so the median we're going to find at 10. We're just going to draw a line across and down, and that looks like it is 17. So our median will be at 17. So we're just going to draw a line at 17. Get it just perfect. There we are. Okay, next thing we're going to look for the lower quartile. So if the median we drew a line across at 10, the lower quartile would do it at 5, which will be here. So that's at 12. So we're just going to draw a line up from 12. Fill in this box, and we can actually fill it in with the lowest point. And lastly, we need our upper quartile, and we do that by adding the 5 and the 10 together to make 15. So we'll draw a line across from 15 and down, and that's 23. So a line up from 23. Try and get this as nicely as I can. I need to move that line a little bit. Oops. There we go. And let's fill in the last bit, join it up with the highest point. And there's our box plot. Here we have a quadrilateral, and all of the corners or vertices of the quadrilateral are on the circumference of the circle. So this makes this a cyclic quadrilateral. And something we know about cyclic quadrilateral is that the opposite angles are not the same, but they add up to 180. So to find x, we do 180 minus 45, and that will give us 135 degrees. And the reason we state is that opposite angles in a cyclic quadrilateral add up to 180. To find the interquartile range from a cumulative frequency graph, you first of all see what the graph goes up to. Here you can see it goes up to 20. And what we do is we halve that, and that's the value we use to find the median. So we halve that again, and that's the value we find for the lower quartile, which will be 5. Then you add the 5 to the 10, so the number we use for the lower quartile to the number we use for the median, and we get 15. So those are the 2 points there that we will find our quartiles. So we draw a line across to find our lower quartile, a line across and down, and I think that is roughly, I think 22 roughly. We do the same again for our upper quartile, line across and down, and that's roughly, I mean these are going up in 4s, so maybe 37, because this line here would be 36, so that would be 37. So to find the interquartile range, it is interquartile range, let's do the formula, is the upper quartile take away the lower quartile. Upper quartile is 37, lower quartile we said is 22, and so 37 take away 22 is going to be 15. Now if you've got slightly different values, that's absolutely fine. The exam will always give a bit of leeway, especially when reading off graphs. If we start by labelling the sides and angles on this triangle, so we can have capital A there, little a, capital B up here, little b, then capital C here and little c. So we don't have the angles A and B, and we don't have length C, but we do have little a, little b, and the angle C. And there's a nice little formula to work out the area of this triangle, and that formula is half A, B, sine C. It's a nice little formula. And so we're going to do half times A, which I've said is 5, times b, which I've said is 4, times sine the angle, which is 24. And when you work that out, you get 4.067 blah blah blah. And when we round that, we get 4.07. When solving simultaneous equations graphically, the solutions are just where the two graphs meet. So we've got y equals x plus 4 drawn, and we've got y equals x squared minus 2 drawn. So the solutions will be here and here. So the coordinates will be x equals minus 2 when y equals 2, and x equals 3 when y equals 7. So with all these circle theorem questions, there's multiple ways of doing it. I'm going to show one way, but if you've got a different way and you get the right answer in correct methods, then please feel free to use that. First thing I'm going to notice is we've got a lot of tangents touching radii. So we've got two radii here and here. And whenever we've got a tangent touching a radius, it's always going to be 90 degrees. And so I'm just going to show these all on the diagram as 90 degrees. And then we're going to say angle OBC equals angle OBA equals angle ADO equals 90 degrees. And we have to show the reasons. Most of the marks in this question will be for the reason. So it's going to be a tangent radius equals 90 degrees. And try and write out the full reasons. I'm going to just keep it a little bit contained, just so I can fit this answer all on the same slide. Okay, so the first thing I'm realizing is that there's a nice little quadrilateral here. And whenever we've got quadrilateral and we've got three of the sides, we can work out the last one. So angle DOB is going to be 360, take away the angles that we know, so 90 plus 90 plus 48. And the reason for that is angles in quadrilateral add up to 360 degrees. And so when you do 360, take away that, you get 132 degrees. So this is 132. But we also have this angle here, which is also angle DOB, but I'm going to call this kind of the reflex one. And to work this one out, we just do 360, take away 132. And the reason for that is angles on a point equal 360 degrees. And so we're going to do 360, take away 132, which is 228. So this is 228 degrees. Now we can also use the circle theorem to work out this one, because we've got an angle at the centre and an angle at the circumference, and the angle at the centre is twice the angle at the circumference. So angle DFB is going to be 132 divided by 2. Angle at centre twice angle at circumference. Okay, so when we halve that, so 132, and we're going to halve it, so that's 66 degrees. We should really put degrees on these. Okay, the next one we're going to work out is this angle here, which is angle OBF. There's no reason for this, it's just the whole thing is 90. We're taking away the 77, so that would be 13 degrees. So that's a nice easy one. And let's just put the 66 degrees on our diagram as well. And the final thing really here is that we've got a quadrilateral here, kind of arrowhead. And we've got three of the angles, 1, 2, 3, and we're looking for the third one. So angle ODF is going to be 360, take away all the angles that we know, so the 228, the 13, and the 66. And the reason being the same as before, so angles in quadrilateral add up to 360 degrees. And when you do that, you get the answer of 53 degrees. So this angle here is going to be 53 degrees. So we first of all need to work out the frequencies in each of the bars. And we know that the frequency density is proportional to the frequency over the class width. So we're just going to go through each of these bars and work out what the frequency is. So all we need to do is times the frequency density by the class width. So 4.8 times 10 is 48. The second one is 0.4 times 10, which would be 4. And then the last one will be 0.8 times 5, which will also be 4. Work out the total frequencies. So it would be 48 plus 4 plus 4, which will be 56. So 56 in total, lines in total, and they only want to see the largest 20%. So we're just going to work out 20% of 56, which we can do, we can just multiply it by 0.2, and that'll give us 11.2. Now you can't have 0.2 of a line, so we can just round that to 11. We're going to start by creating a table of frequencies from this histogram. And so we are going to need our times, first of all, then our frequencies, and then we can add a midpoint and an fx column as well, which we'll need for later. So our times, then our frequencies, then our midpoints, then we'll do the fx later on. Right, so the first group is 0 to 10. And to find the frequency, I might as well just show this. So the frequency density is proportional to the frequency over class width. The class width here is 10, and the frequency density is 1.2. So 10 times 1.2 will be 12. And then the next group is up to 30. So we're doing 20 times 3.2. which will be 64, and then the final one will be 30 to 50. So again, we're doing 20 times 0.8, which will be 16. Okay, so we've got our table from the histogram, and we're asked to find the mean, so hence us doing the midpoint, etc. So the midpoint is 5, 20, and 40, and then the fx, we just times these together, and that would be 60, 1280, and 640. Now, something I said earlier is that the frequency density is proportional to the frequency divided by class width. It does tell us there are 92 people, and if you do the sum of the frequencies, you do get 92. So we know that it's a one-to-one relationship. Okay, so let's do the sum of the fx by adding up these numbers here, and you get 1980. So to find the mean, we do the sum of fx over the frequency, sum of the frequencies, and that will give us 21.521, blah blah blah, and 2 decimal places, which is what the question asks for. It's 21.52. We're going to start by working out what outcomes will give us 2 different types of drink. So we could have OA or AO. We could have AW or WA, and we could have OW or WO. Now, what we notice really when we do this is that OA gives us the same probability as AO, same with AW and WA, same with OW and WO. So we're going to just ignore the right hand side ones, and we're just going to focus on the left hand side ones. To work out the probability of O and then A, so orange juice then apple juice, we work out the fact that it's 6 over, well, the probability of picking orange juice first of all is 6 over 27. And then if we picked an orange juice, the probability of picking an apple juice would be 9 over 26. And so that would be 54 over 702. Apple juice then water would be 9/27, and then 12/26, and so that would be 108/702. And then orange juice then water will be 6/27 and 12/26, and that would be 72/702. Now we're looking at the probability of this or this or this, and the word or means add. So the probability of OA or, I should put that in brackets, probability of OA or AW or OW is these added together. And when you add them together, you get 234/702. Now, I said we would deal with the reverse situations now. I'm going to deal with that now. And as I said, OA is going to be equal to AO, AW is equal to WA, and OW is equal to WO. So all we need to do to find the probability that the drinks are different is get the 234/702 and just double it. And we can do that by just doubling the numerator, so 468/702. That cancels down to 2/3, so there is a 2/3 chance that the drinks will be different. A line that has a gradient of 0 will just be a horizontal line. So if you get your ruler and you just have a horizontal line on your ruler, so just have it as a gradient 0, and just keep moving down this graph until it becomes the tangent of the curve. So if you see, it becomes a tangent to that curve here. Where is it a tangent to? Well, it's a tangent to this coordinate here, which is at x equals 2.5. So we've got x equals 2.5, and you can see the y is 2. So the coordinates are 2.5 and 2. As always with this type of question, we want to represent the three-dimensional shape with two-dimensional shapes. So we're going to start off with a right-angled triangle between BD, E, and then back to B, and we're just going to draw it out. And so we've got 5 centimeters here, 3 centimeters here, and we've got the length BD here. So what we're going to do is we're going to use Pythagoras to find out what the length BD is. So BD squared equals BE squared plus ED squared. And let's get our tram lines in. So we know that BE is 3, and we know that ED is 5. That's going to equal 34. Square root both sides, and we've got BD equals, and we can leave this as just square root of 34, but if we want to write out exactly what it is, then it's 5.830 blah blah blah, and we're going to keep that into our calculator. Next we're going to work out distance MD. Now M is in the, like, it's a midpoint in this diagram, so we just all we do to work out what MD is get BD divided by 2, and that's going to equal 2.915, etc, etc. I'll keep it in my calculator still. Now the next right angle triangle we want to draw is to find out, in fact I'm going to pick a different colour because that's a bit too similar. Let's go for a purple. So we're looking at this triangle here. So let's draw that one out. Okay, so we've got 6 centimeters down the hypotenuse, and we've got this 2 2.915 blah 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 down the bottom, and we're looking for angle ADB. So it's ADM or ADB, which is this one here, and ADB and ADM will be exactly the same because you can see that B and M are the same angle from D. Okay, so we're going to use trigonometry for this because we've got two lengths and an angle in a right angle triangle. So labeling the sections, we've got the hypotenuse here, we've got the adjacent here, and we're not using the opposite at all. So the adjacent and hypotenuse means we'll be using cos, C-A-H, and so it's going to be cos brackets ADB is going to equal the adjacent over the hypotenuse. Let's get our tram lines in. Okay, that's going to equal 2.915 blah 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 over the hypotenuse, which is 6. Now we're going to inverse cos both sides to get rid of the cos on the left hand side. So we've just got ADB equals, and it will be the inverse cos of 2.915 blah 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 over 6. Now I'm keeping that in my calculator, so what I'm going to do is inverse cos, which will open a bracket, and then fraction button, and then answer over 6, and that gives me 60.927 blah blah blah. It says it wants its two decimal places, so it's two decimal places, that will be 60.93. We're going to first of all work out what the function f g of x is, and to do that what we're going to do is just feed in the value of gx, the function, the kx plus 2. We're going to feed that in as the value of x in the f of x function. So instead of 4x, it'll be 4 lots of kx plus 2 and then plus 3. Now this says that fg, when 4 is put into it, it gets an answer of 187. So when 4 is put into it, well, let's put that 4 into it. So 4 brackets, and it's k times 4, so that's 4k, plus 2, plus 3. And it says that that will equal 187. So we've actually got something we can solve here. So I'm just going to rewrite that, but actually I might expand the brackets as well while I'm at it. So 4 times 4k is 16k, 4 times 2 is 8, plus 3 equals 187, and let's get our solving lines in. Okay, so first thing we're going to do is, well, we can add the 8 and the 3 actually while we're here. So 16k plus 11 equals 187. So we're going to take away that 11 from both sides. So we've got 16k equals 176, and then we can divide by 16 both sides. So we've got k equals 11. So answer is 11. I'm going to start off this question by finding length BD, and we do that by doing a little right angle triangle down here, and let's draw that right angle triangle out. Okay, so we've got a length of 4 on ED, length of 3 on BE, and we're looking for length BD. So we're going to use Pythagoras. So we've got BD squared equals BE squared plus ED squared. Get our little tram lines in. Okay, so BE is 3, so it's going to be 3 squared plus 4 squared, and that's going to equal 25. Square root both sides, and we've got BD is equal to square root of 25, which is just 5. Okay, we need to now work out what MD is, because we're looking for length AM. So MD is actually just going to be half of BD. So it's going to be half of 5, which is just going to be 2.5. The reason for that is that all of the lengths AB, AC, AD, AE, all of them are the same, so therefore point A will be exactly at the midpoint or above the midpoint of the square, so M is obviously at the midpoint. Okay, next we're going to draw in another right angle triangle. It doesn't actually matter which side we take. I'm just going to take this side because we've worked out what MD is. And let's draw that out down here. Okay, so we've got the length of 5 here. We know the bottom bit is 2.5 and we're looking for the length AM. So another bit of Pythagoras here. So AM squared is going to equal, and we're looking for AM, yep. AM squared is going to equal AD squared, take away MD squared, and AD squared is going to be 5 squared minus 2.5 squared, which is going to equal 18.75. Then we'll square root both sides. I haven't put my tram lines in. Let's get those in as well. Make sure it's all neat and tidy. So we've got AM is equal to 4.330, and because it says 2 decimal places, we want to write down the answer 4.33 centimeters. Okay, so we're given the fact that this is a graph of y equals cos x, but it also says that we're looking for solutions for cos x equals minus 3/4. So if you look at those two things, you'll realise that y equals minus 0.75. And if we plot that on our graph, and it's a bit of an estimate, it doesn't have to be perfect, you can see that there's 2 points which it crosses the graph. Okay? Now, we need to work out what one of these points is, and the way we do that is we do the inverse cos of the minus 0.75, and we do that on a calculator. 138.590 blah blah blah. Now the problems with calculators is they will only ever give us the first solution, so this solution here. They can't give us all the solutions because there are infinite solutions, because this graph is going to go on forever waving up and down, okay, and crossing that line which we've drawn in blue on the graph. So it gives us the first one. The calculator will always give us the first solution, but we can use symmetry to find the next solution. If you look at the graph, we've got this point here, and the whole graph, if I draw a line up, the whole graph is symmetrical. Okay, do you see it? The whole thing is symmetrical. So if the distance here, so the distance between the start and here is 138.590 blah blah blah, then that distance must be the same distance as here. That must also be 138.590 blah blah blah. So to work out what this coordinate is, all we need to do is 360 take away the 138.590. So 360, which is here, take away this bit here that we know, and that will tell us what this bit here, what this coordinate here is. And so we've got, type that into the calculator, you get 221.409 blah blah blah. We want the answer to 2 decimal places, so the first solution is 138.59, and the other solution is 221.41. So you can complete a unique version of this paper by going to our OnMaths site. OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.